Assalamualaikum and salam sejahtera. Today I'm going to teach you how to fit data with a shallow neural network by using a MATLAB. Okay, to solve the problem, we have to use a general user interface and also use a command line. Okay, for this tutorial, I'm going to use a general user interface. Okay, all you have to do is just write this NF tools in the command line and you click run. Okay, in this will pop up a window to show a brief understanding on neural fitting apps. Okay, for the neural network, it show you a two-layer feed-forward network with a sigmoid hidden neuron and linear output neuron. Okay, all you have to do is just press next. Okay, it will pop up a selection data there. Okay, if you have your own data input and your own data target, all you have to do is just press this one to put your own data. But in this case, in this tutorial, I'm not going to using my own data. I'm going to use the example data set that have been uploaded in this GUI. All you have to do is just press the load example data set there, and then it will came out with the bunch of the example training data, bunch of a data set there. Okay, it have a chemical, engine, building energy, body fat, balloon rings, hot pressing, and simple fitting problem. Okay, in this tutorial, I'm gonna choose a chemical data set which can be used to train a neural network to estimate one sensor signal from 8 other sensor signal. All you have to do is just import a data set there. Okay, as you can see is the chemical input has been uploaded. The chemical input data has been uploaded into the input, while the chemical target has been uploaded into the target. Okay, this is a summary of the example data set there. It have 8 times 498 metric, which represent static data, and also 1 times 498 metric, which represent static data there. All you have to do is just click next there, and then this is the validation test data. Okay, validation test data is set is 15% of the original data. With this setting, the input vector target vector will be randomly divided into 3 set as follow. Okay, this is the explanation of the 3 kind of sample to you understand more about this validation test data. Okay, all you have to do is just press next. Okay, this is a network architecture where you can set your own hidden neuron there. Okay, the default number of the hidden neuron are set to be 10. If you want to increase this number later, if the network performance is poor, you can set whether to use a 100, 1000 or many, but in this case neuron are set to be 10, and then you just click next, and then this is a train network algorithm. Okay, we use a Levenberg Marquardt, which is recommended for most problem, but for some noisy and small problem, we can choose a Bayesian regularization, and if for large problem, we can use a scale conjugate gradient for better solution. Okay, all you have to do is just press the train, and then it will pop up this window. It's a neural network training tool. Okay, the example of the default Levenberg Marquardt, then we use a Levenberg Marquardt and performing show a mean square error there. Okay, the training is continue until the validation error at for iteration is stop at 6, and then you can plot your performance there to validate the network performance. For regression, all you have to do is just press the regression, and then it will pop up the regression plot there. As you can see, the following regression has been plotted displayed to respect to the target for training. For perfect fit, the data must set to be must set must fall along between the 45-degree fit line there. Okay, and then you can see the error histogram there. For to obtain the additional verification there, all you can see is the blue bar there is a training data, the green bar there is evaluation, and the red bar is the test. Okay, the histogram can indicate the outliers, which are data points where the fit is significantly worse than the majority of the data. In this set data, the error is fall between -6 until 3. Okay, after that, if you can press the next button. Okay, this is the evaluate the network. Okay, at this point you can test the network against a new data. If you dissatisfied, you can train again. If you want to set a larger data, you can import your larger data set there. Okay, after that you just press next button. Okay, this is a panel function for simulating diagram, to simulate your neural network there. You can use the generated code to do a general solution after this. Okay, all you have to do is just press next to generate the script. Okay, this is the script to reproduce a result to solve a similar problem that you have, and then it can generate a script. Okay, it have a simple script and also the advanced script there. Okay, to create a MATLAB, to create a pseudocode there, to reproduce all the previous step for the command line. Okay, all just if you press as advanced script there. Okay, this is the script that produce the various previous step from the command line there. Okay, that's all from me. Thank you.